Welcome to the Serebryansky Forest, Ukraine. It's 10 hectares of hell. It's a dense canopy of pine, mixed timber, shattered by continuous artillery and saturated with drone surveillance. Surviving here requires heavy armor to navigate the tight, high transparency environment. To hold this line, Ukraine's 21st Separate Mechanized Brigade relies on a specific piece of hardware, the Swedish-designed Combat Vehicle 90, or the CV90. This is an infantry fighting vehicle, a class of armored transport that carries troops into battle while providing heavy direct fire support. Most Western Infantry Fighting Vehicles, like the American M2 Bradley, survive by absorbing incoming fire. They use a thick steel of explosive reactive tiles to defeat kinetic strikes, which adds immense weight and bulk to the chassis. The CV90 takes a different approach. Instead of maximizing brute force protection, its engineering prioritizes extreme mobility, thermal signature management, and programmable ballistics to dictate the terms of the engagement before taking a hit. This design philosophy stems from its origins. Developed in the 1980s by the Swedish Defense Materiel Administration, the CV90 was built specifically to operate in the sub-Arctic conditions of Scandinavia. The environment demanded a low-profile chassis with high ground clearance to navigate the deep snow and wetlands. Those same sub-Arctic design choices map directly into the Ukrainian theater. The vehicle's wide tracks and low ground pressure allow it to glide over deep mud and rugged terrain of the Eastern Front, outmaneuvering older, heavier Soviet-era platforms that frequently stall in the muck. Inside the Serebryansky Forest, the CV90 serves as a real-world testing ground. The combat data generated here proves that minimizing a vehicle's physical and thermal footprint is a highly effective method for keeping crews alive in a modern, drone-saturated warfare. The 21st Brigade executes a maneuver known as the Shield and Sword to protect their infantry. Because Russian units prioritize the CV90 as a high-value target, the crew deliberately uses the vehicle's armor to draw incoming fire and the drone strikes away from the troops as a dismount, an action known as a descent, to assault the trench lines. To absorb incoming fire, the CV90 relies on a structural layer shown here, Advanced Modular Armor Protection, or AMAP. This composite kit dissipates energy from tandem charge warheads inside a synthetic spall liner, catches the secondary metal fragments, preventing them from re-shedding around the crew compartment. The combat record validates the engineering. Despite several CV90s taking documented direct hits from rocket-propelled grenades and kamikaze drones, there are 0 confirmed fatalities among the Ukrainian crews operating them in the 21st Brigade. Beyond the physical plating, the CV90 utilizes a soft kill defense. Mounted electronic warfare system broadcasts a dome of radio frequency interference that severs the link of incoming drones. This is paired with Saab's Barracuda camouflage netting and matching the vehicle's infrared signature to the ambient forest temperature. Outfitted with this netting on the front lines, the vehicle becomes incredibly difficult to isolate on an operator's thermal display. The CV90 survives by masking its presence and disrupting the electronic signals required to target it, negating an attack before the physical armor is even tested. When it is time to strike back, the vehicle utilizes its primary weapon, the 40mm Bofors L70 automatic cannon. The 40mm 3P round packs 1100 tungsten pellets. Using a laser rangefinder, the gunner measures the exact distance above an enemy trench. A muzzle programmer sets the electronic fuse as the round exits. It detonates at the designated point, projecting a dense, downward shrapnel cone. A single burst sends over 1,000 high-velocity tungsten fragments tearing through the pine branches and into the earthworks below. This negates the geometric advantage of a trench. Traditional direct-fire weapons require a line of sight of the target, but an airburst angles the fragmentation straight down, bypassing the earth walls entirely. By turning the timber canopy itself into amplifier for the blast, the 3P system allows a single CV90 to clear complex defensive lines in seconds, achieving a total trench denial. Looking at this wireframe profile, the 40mm gun possesses a high elevation limit of positive 80 degrees. Ukrainian crews exploit this angle to use the CV90 as a substitute for self-propelled artillery, lobbing high explosive rounds into parabolic arc to suppress distant staging areas. Against heavy Russian armor, the CV90 lacks guided missiles, Instead, it relies on its speed to outflank main battle tanks, firing armor-piercing fin-stabilized discarding sabot rounds, dense kinetic darts designed to penetrate the thinner steel on the sides and the rear of the enemy chassis. This combination of high-angled suppression and rapid armor-piercing capability bridges the operational gap between lightly armed personnel carriers and slow, heavy tanks. Based on this amazing performance, Sweden, Denmark and the Netherlands signed a $2.5 billion contract in late 2024 to supply Ukraine with the next generation of platform, the CV9040C. This blueprint illustrates the new variant. It upgrades the main gun to a 35mm Bushmaster and introduces the D35 turret. It incorporates an artificial intelligence integrated fire control system for faster target acquisition. And it's designed to mount the Iron Fist active protection system, which uses radar to detect and intercept incoming projectiles before they strike the hull. Beyond imports, Kiev has signed agreements with Sweden to establish domestic co-production facilities. The long-term objective is to manufacture up to 1,000 standardized units directly on Ukrainian soil. This secures a reliable hardware pipeline that reduces Ukraine's reliance on older Soviet stockpiles and fragmented Western donations. Born in the deep snow of Scandinavia, the CV90 has adapted to the mud and timber of the Eastern Front. By prioritizing stealth, mobility and programmable precision over sheer mass, it provides a highly effective blueprint for modern mechanized defense.